Welcome to Web Handling. My name is Dave Roisum. I am very excited to introduce a new mini-series on web machine design reviews. Whether you're thinking about a machine purchase, or already in the process of purchase, or even if you already have a machine, you will want to stay tuned. The reason is quite simple. Your web machine is as important to your business as are your operators, customers, marketing, and products. Without a machine, there is no business. Without a good machine, the business is also not good. Most people think of doing a design review as part of a machine purchase. Typical points in the project where this is most commonly done is prior to a request for quote, prior to a purchase order, and prior to releasing drawings to purchasing or to the machine shop. It is important to catch things early, as the longer you wait, the more expensive change orders become. However, you can also do a design review on an existing machine. In many ways, this is much easier. You don't have to use the engineering version of a crystal ball to anticipate problems. You already know what they are. All you need to do then is to figure out why they are. Sometimes it is due to your machine limitations, such as machine design, or machine operation, or machine maintenance. To get started, we need to know certain web properties that will be used to size the machine. Width, strength, thickness, and modulus all figure in strongly in sizing components such as rollers and drive components. Those who have studied web handling will note that chemical properties in themselves are relatively unimportant for web handling. What is important for web handling are mechanical properties. Thus, we might anticipate that nonwovens and tissue will share similar sets of challenges because both are fuzzy, even though they have different chemistries. We can get into big troubles before we even start. That is, to build a do-everything machine, which inevitably does most things poorly. Examples here abound, but would include things like wide variations in web width or web strength. Anything beyond about a 4-to-1 ratio of strengths might be a slight challenge for rollers, but nearly impossible to do well for drives. Yes, there are design tricks to extend the range a bit, but they add cost and complexity to the machine. Stretching the parameters of the machine is attractive because it allows a wider scope of products to be made. However, stretching specification also inevitably increases costs, both at the time of purchase as well as for the life of the machine, due to increased waste, delay, and customer complaints. Companies with many machines may have the luxury to dedicate a workhorse machine to a few similar bread and butter products, and then quarantine odd products to the less productive machines. In addition to variation of web properties, we also must be aware of certain nominal properties that are known to cause troubles. Brittle materials tend to have more web breaks and up the demand for both roller and drive precisions. A tender side of the web, such as uncured coatings, may not allow touching on that side, and that greatly complicates web routings unless air turns are used in lieu of rollers. Both low and high COF webs can cause troubles, especially at the winder. Sticky or tacky webs bring these tribology troubles to an even higher level of concern on both rollers and rolls. Intentionally profiled products where thickness varies can be causing great web handling challenges, especially at the winder. We may need to limit roll diameter or oscillate the roll to keep the high caliper areas from stacking up and misbehaving at the resulting high pressure areas. Bagginess is the most common outcome for winding profile troubled materials. Finally, geometric changes in length and especially width due to hygrothermal expansion can cause huge grief with MD wrinkling at levels as small as a few parts per thousand. Creep, which is the permanent change in geometries due to web stretching or winding, is also extremely risky. For products like this, it is best to have a lot of similar prior experience to be able to estimate risk. These concerns are far too much to cover in this short clip, but are covered in great detail in my Web 101 training course. Anyone buying or selling or operating machinery would benefit from the must-know topics covered there. There are many machine parameters that are also vital to success that are too broad to cover here. Even so, there is a general strategy to make sure that all the bases are covered, so to speak. That is, to include a broad set of talent to look at key steps in the project. That would include engineers from the builder and buyer alike, as well as a representative from purchasing, management, marketing, maintenance, and especially operators. For expensive or risky projects, you may wish to consider hiring an outside expert for a few key points in the process. In any case, a diverse set of eyes will uncover more than even the most capable engineer from a builder or buyer can. There are a lot more project details that you need to know to boost your chances for success that we simply can't cover here. Fortunately, it is all covered in a dozen chapters of a book that spans from economic justification to startup and beyond. A question you should be asking before playing any more of these clips is why bother with all of this? There are several reasons. First, all machines, whether they are as simple as the electric toaster in your kitchen to the most complicated coder laminator, are full of inevitable compromises or trade-offs. Trade-offs are inevitable and are not necessarily a bad thing in themselves. Perhaps you don't need or want a toaster that has a setting for bagels. Or perhaps you need to do 4 slices instead of 2. However, if you buy a 4-slice machine, it will be bigger, more expensive, and toast more poorly than a dedicated 2-slice machine run as 2 batches. What you want, however, is to make sure that the trade-offs and compromises made on this new machine make the most sense for you. The second answer is a bit more troubling, but no less true. That is, every machine has avoidable errors in design or manufacturing. Sometimes these are a mere nuisance, such as excessive rollers. Other times they are limiting or even debilitating, such as excessive deflecting rollers or a poor drive implementation. The earlier you or someone else catches a less than optimum trade-off or a clear design error, the cheaper and better will be the remedy. Indeed, Once the machine is built, many remedies that could have been made at little or even no cost may then become economically prohibitive. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we will continue the design review process by listing the vital process steps that are required, as well as any options we might want to consider.